Hello everyone. In this video, I would like to talk about the ERD, Entity Relationship Diagram. By Entity Relationship Diagram, it is a very important high-level analysis tool for designing databases. So, entity is something that we will store in the database, and it's something. So relationship in an application, there could be many different kinds of entities. So there are relationships among the entities, and we will use the relationship to represent the association of the different kinds of entities. So it's a graphical tool. Let's think about a complex, maybe for a complex database application. Although we have already learned how to normalize from the first normal form to third normal form, of course we can just read the problem description and then list all the attributes as a very big table, and then determine all the candidate keys. Based on the candidate keys, we can perform the functional dependency analysis so that we can optimize the database table design from first normal form to third normal form. However, when we have a lot of attributes, it's not easy to determine all the candidate keys. So based on this issue, sometimes we may just base on some intuitive separation of the data, that we may group a few attributes as a table, and then based on the groups, that means tables, then we perform the optimization or the normalization. However, this is based on the intuitive approach, and this is not science. So according to science, there should be some systematic way. So even in a very high level analysis tool, we can use some not really intuitive, but some systematic approach to design the initial database structure or the database schema, and then perform the functional dependency analysis, then get the and remove all the redundancies. So this is based on the knowledge, domain knowledge. Based on the domain knowledge, we can use the ERD to prepare the initial design of the database. So by ERD, entity is represented as a rectangle, and inside the rectangle we specify the name of the entity and some other attributes. So the first line is the entity name, and the following lines are the attributes. For the primary key, we use the underline to denote the primary key. So suppose we have two entities, and they have relationship, so they are related, different kinds of concepts. So they are related. So we draw a line to represent the relationship. However, this is just a rough description. That means the left-hand side entity and the right-hand side entity are related. So for the relationship, we have some more detailed tools to specify the constraints of the relationship. For example, if we draw the end as a claw, right? That means it is multiple. So one left-hand side entity instance corresponds to multiple right-hand side entity instances. And we may further specify the minimum number by a circle, that means optional, okay, 0 or more, by a short vertical bar, a short bar, that means at least 1. Right? So we may specify the relationship like this. Okay? This is called cardinality. Okay? Cardinality. So now, for a relationship, we need to interpret the relationship from two viewpoints, one from the left to the right and the other from the right to the left. So suppose on this diagram we have left entity. One left entity corresponds to multiple right entities, and in the reverse way, one right-hand side entity corresponds to one left-hand side entity. So this is the interpretation of a relationship. Basically, I prefer to use two sentences to clearly specify the relationships. So let's back to our previous example, the expense tracking. It's quite simple. Then let's try to analyze this application using ERD. So we have a concept, a concept of data called expense, and we physically at a given time instant, we at in a certain place, we have the expense. So timestamp, amount, and place, and timestamp is the primary key. Okay. Then, given an expense record, we have some additional descriptions. That means the purpose of the expense. So, say in our example, to watch a movie, it could serves. The watching the movie can be categorized as the recreational activity or an educational activity. So here I intentionally use a different term. Let's call it purpose. Purpose. So given a purpose category, we can specify that given an expense, there should be at least one purpose. It could be multiple, at least one purpose. Then, when we interpret in the reverse way, one purpose could be used. Could be used in multiple expenses. For example, the food, purpose for eating something, can be used in a lunch expense or dinner expense. However, it is possible that no expense record corresponds to the given purpose, so it's optional. So 0 or more, and you could see that the relationship is many to many. Many to many relationship. By many to many relationship, unfortunately, in relational model, we don't have a tool to represent many to many. So, to make it fit into a relational database, we need to transform the ERD to kind of one to many. Because in relational model, remember we have the primary key, foreign key relationship. So it's basically a one-to-many relationship. So let's transform our diagram. The transformation is quite simple. We preserve the original two entities, so expense and purpose. Then we add an additional entity. Sometimes to indicate that this entity is used for associating two entities, we use rounded corners, and so sometimes we call it associative entity. Now let's see. The relationship is designed like this. When we start from expense to purpose, we just move the one-to-many relationship to the expense and the associative entity. Similarly, from purpose to expense, it's one to optional many. So we put optional many here, and here is one. Two short bars means at least one, and the maximum. Minimum cardinality is 1, maximum cardinality is 1, so that means only 1, exactly 1. Okay, so this is the transformation of the diagram notations. Then, for an associative entity, we also need to give it the name. Before that, let's complete the diagram. For expense, we have timestamp, amount, and place. For the purpose, we have a name to short name for the purpose, and it's the primary key, and the description. For the associative entity, if there's no natural name for the associative entity, one possible naming scheme is to use the concatenation of the two entities. So we call it expense, purpose. And the primary key could be the combination of the timestamp and the name. So it's a composite primary key. On the ERD, a composite primary key is a comma-separated list of the key components and use parentheses. So we use parentheses to group a few attributes as a composite attribute, and then use an underline. Actually, sometimes we just we use a name to distinguish the composite attribute. However, here I just use the short representation. So now we have the three entities designed, and later you may currently you may think about the differences between the current design and our previous third normal form design, and later we will compare the two, and we will find a minor issue. So let's quickly recap what we have learned in this video. We learned entity, relationship. For relationship, we can specify the cardinalities, and based on the cardinalities, if it's a many-to-many relationship, we can reformulate or redraw the diagram, transform the diagram to use an associative entity, and by using the associative entity, we can preserve the original many-to-many relationship, and while we can use the three entities to fit into the relational model. Okay, so this is what we have learned, and please think about this design and our previous design. In the next video, we will compare the two.